Hey guys, so welcome back. And today I'm going to walk through into my latest project using SEMMA methodology to analyze and model the student's performance dataset. So SEMMA stands for Sample, Explore, Modify, Model, and Access, a methodology originally designed by SAS for structured data mining. In this project, I used to predict student performance, identifying what factors led to academic success. So here's an overview of the five phases. So sample, so choose and split data, explore, understand the patterns and relationships, modify, prepare and transform the data, model, build and train predictive models, access, evaluate how well the models perform. So we can walk through each of the steps. So for now, I have added the CSV file into my Google Drive, which I am accessing. And for now, I have labeled all the columns, which are based off of gender, race, parent education, lunch type, preparation course, and scores based off of their math, reading, and writing. So for the next two target classification label, so whether a student is a high performer, so the average score is more than 70%, and regression target, the continuous average score. So coming to the sample. So in the sample phase, I split the data into 80% training and 20% testing sets. For classification, I use a stratified sampling for to preserve the ratio of high and low performing performers. So this ensures that both sets represent a real population fairly. So this is the output given based off of the sample. So now coming to the explore phase. So I looked at the score distributions, correlations, and differences across categories. A few insights stood out. So students who have completed a test preparation course scored significantly higher. So those with free or reduced lunch generally scored lower, a possible indicator. So, and also comes down to parental education level, showed a clear upward trend in scores. So this exploration gave me hypothesis to test during modeling. And then once I run this part of the code, it gave me an output of this. So as you can see, we can see the average score distribution and the high performer counts. And this is the average score by gender, if you go by male and female. And this graph is me. It's used by race, and this was based off of the parental education. And lastly, coming down to the lunch, based off the lunch standard and the free, and then the test prep, if they're going to test prep or not. So for coming now to the modified, so I handled the missing values, scaled numeric features, and one high encoded categorical variables. So this standardizes the data, ensuring fair contribution from all attributes. I built a reusable pre-processing pipeline in Skikit learns, so the same transformations apply consistently to both the training and test data. So we only take consideration the reading, writing, and math. Then the gender, race, parent education, lunch, and test prep. So now coming to the model phase, the heart of SEMA. For classification, I started with a logistic regression baseline and trained a histogram gradient boosting classifier, which achieved as a rock AUC of around 0.92. For regression, I completed a rigid regression with the random forest regressor. The random forest achieved of R power to the 2 of 0.93, meaning it explained 93% of score variance. pretty solid. And this is the given output based off a classification of the reg. And then now coming to the access phase, testing how well the models generalize. For classification, I evaluate ROC and the precision recall curves and even calculate the recall at top 15%, simulating a intervention scenario. How many top performers we could identify with limited resources. For regression, plots showed no major bias or didn't show any changes, and confirming that the model's predictions are stable across score ranges. So as you can see, this is the output given over here based off a recall and the top K and the regression graph. So this is the output. So what we learned today, what I learned today, completing a test prep course is the strongest driver of high performance. Lunchtime, a proxy of income, correlates closely with achievements. Parent education has a measurable positive influence, and interestingly, gender's differences are minimal. And to wrap up, the SEMA process provided a clear, uh, repeatable workflow from sampling and exploration all the way to access, assessment, and insight. In the end, I didn't just build a model, I built understanding. And thank you so much for watching.